In terms of nucleophile, the SN2 reaction needs to have the right nucleophile for it to happen. So again, let's just analyze the pentacoordinate intermediate, the transition state for the SN2 reaction. The nucleophile needs to approach the carbon opposite of the leaving group, and the carbon is not positive, it's partial positive. So this nucleophile needs to know what it's supposed to do. So I need a strong nucleophile for an SN2 reaction. And it just so happens that most of the strong nucleophiles are going to have a negative charge. So I can have the hydroxide ion, I can have cyanide, which we saw in the previous one. I can have the halides. I can substitute a halide for a different halide if I want to. I can have the azide, which is N3 minus. It's a good one, and we're going to see it when we get to the synthesis of amines. We also have sulfur, and the sulfur, to be a good nucleophile, it does not need to be negatively charged. It helps, but it doesn't need to be negatively charged. So you can have the sulfur with a methyl attached to it or a hydrogen attached to it. And then we have a nucleophile that's a strong nucleophile even though it does not have a negative charge, and that is ammonia. So ammonia is a strong nucleophile even though it doesn't have a negative charge. The rest of our nucleophiles, they all have a negative charge. So I need a strong nucleophile for an SN2 reaction to be able to happen. In terms of weak nucleophiles are not going to be able to form your pentacoordinate intermediate, because a weak nucleophile, it's not strong enough to actually find a partial positive carbon. That and the pentacoordinate intermediate is going to have a lot of steric hindrance. But if you want to know what is a nucleophile, a weak nucleophile is, most of the time we're just going to stick with water, but we can also have alcohols in there. So for an SN2 reaction, I need a strong nucleophile. If you have water or you have alcohols, those are not good enough to do an SN2 reaction.